Objective 3. Explain Simpson's paradox. At this point, we know how a lurking variable, which is an explanatory variable that was not considered in the observational study, but that affects the value of the response variable, can cause two quantitative variables to be correlated even though they are unrelated. This same phenomenon exists when we explore the relation between two qualitative variables. Okay, now in this example, gender bias at the University of California, Berkeley. The table above show the admission status and gender of students who apply to the University of California, Berkeley. Now from the data in the table, the proportion of accepted applications is the following: 1,748, because when you add the men and the women, we get 1,748, okay? And then we're going to divide it by the total in the table, and that gives us 0.395, okay? Now the proportion of the accepted men is the following, okay? We're going to take the following. We're going to take the men, which is 1,191, and then we're dividing it by the total of the accepted men, which is 2,590, which gives us 0.460. And the proportion of the accepted women, again, this is the accepted women because we're looking at the accepted part, and then we're dividing it by the total. So the accepted women is 557, and then dividing it by the total of 1835 gives us 0.304. Now, on the basis of these proportions, a gender bias suit was brought against the university. The university was shocked and claimed that the program of study is a lurking variable that created the apparent association between admission status and gender. The university supplied the table below in its defense. Now, we want to develop a conditional distribution by program of study and use it to defend the university's admission policies. Now here is a table. It says admission status. Accepted is A, or not accepted is NA. And for the 6 programs of study, which the 6 programs of study is A, B, C, D, E, and F by gender. So we have our men. So if we take a look at men here, for program of study A, accepted is 511, not accepted is 314 for the men. Now for the women, accepted is 89, and not accepted is 19, and that's for the program of A. Okay? So, again, I'll go ahead and we can just highlight that so that we can see what each one looks like. So, here is program A, and then this represents program B, program C, program D, program E, and then program F. Okay, so what we want to do is we're going to create the following. So we have our men and then women, and you can see at the top we have A. So let's go ahead and take a look at that. So if we look at the first program, which is A, there is our A. And what we're going to do is we're looking at where it is accepted. So for men, how many were accepted in program A? Well, how many were accepted were 511. Okay, and then how many total were there in that for men? Well, the total was 511 plus 314. So 511 plus 314 is going to give us 825. So if we take 511 divided by 825, that gives us 0.619. Now let's take a look at women. So if we take a look at the women program, we can see that the ones that were accepted in program A was 89. And then we're going to take the denominator, because we're going to add those two values together. So we're going to take 89 and then add the 19 to give us 108. So if we take 89 and divide it by 108, we get 0.824. So what does that mean here? If we look at this, that means that almost 61.9% of men were accepted for program A. And for women, we can say that 82.4% were accepted in Program A. Okay, now we're going to take a look at Program B. Okay, so for Program B, we want to figure out how many were accepted. So for men, accepted was 353. Okay, and then we're going to add the total together of 503 and 207. So when we add those together, we get 353 plus 207, which gives us 560. So therefore, 353 divided by 560 gives us a percentage of almost 63% of men that were accepted in Program B. Now, if we take a look at Program B for women, we can see that 17 were accepted. So we know 17 is in the numerator. Okay, to find the total, we're going to add 17 plus 8. So there, 17 plus 8 is going to give us a total of 25. So 17 divided by 25 is 0.68, which is 68%. Okay, now let's take a look at Program C. So if we take a look at Program C, okay, we're going to again look at the accepted for men, and we can see that 120 was accepted. Okay, and then we're going to add those two values, 120 plus 205. So 120 plus 205 gives us 325. So 120 divided by 325 gives us 0.369. And likewise, for women that were accepted, we had 202. And we're going to add these two values together. And so therefore, 202 plus 391 gives us 593. If we take 202 and divide it by 593, then we get 0.341, which is representative 34.1 percentage. Okay, now we're going to look at Program D. So how many were accepted for men in Program D? Well, 138. So that's going to be in our numerator. Okay, in our denominator, we're going to add these two numbers together for Program D for a total of men in that program. And then we can see that 138 plus 279 gives us 417. So 138 divided by 417 gives us 0.331. Okay, for Program A for women, we have a total of 131. Okay, and again, we're going to add up the total of women in that Program D. So when we add 131 plus 244, we get 375. So 131 divided by 375 gives us 0.349. Okay, next we're going to take a look at Program E. Okay, so how many were accepted for men in Program E? Well, we can see that 53 were accepted. And then we're going to find the total of men in that program, which is taking 53 and adding 138. So 53 plus 138 gives us 191. 53 divided by 191 gives us 0.277. Okay, next, how many were accepted in Program E that were women? Well, we can see that 94 were accepted. To find the total of women that were in that program is taking 94 and then adding 299, which gives us 393. So 94 divided by 393 gives us 0.239. And then the last program is F. And so how many were accepted for men in that program? Well, we had 16 that were accepted. We're going to add the total men that were in that program, which is 16 plus 256, which gives us 272. So 16 divided by 272 gives us 0.059. And how many women were accepted in the program? Were 24. So we're going to add up how many women were in that program, which is 24 plus 317. So when we add those two numbers together, we get 341. So 24 divided by 341 gives us 0.070. So now, Again, we determine the proportion of accepted men for each program of study and separately determine the proportion of accepted women for each program of study. A significant difference between the proportions of men and women accepted within each program of study may be evidence of discrimination. Otherwise, the university should be exonerated. So again, how do we find the proportion of men who applied to program A and were accepted? Well, again, we took the total of the men that were accepted in the program of 511, and then we divided by how many men that were in that program, which was 825. So 511 divided by 825 gave us 0.619. And likewise, for the proportion of women applied for program A, we had a total of 89 for women, and we know that the total of women in that program were 89 plus 19. So 89 divided by 108 gives us 0.824. So within program A, we can say that a higher proportion of women were accepted because that's 82.4% compared to 61.9%. Now programs A, B, D, and F are actually had a higher proportion of women accepted because you can see here 82.4% was larger for women than men in program A. For program B, we had 68% compared to 63%. For program D, we had 34.9% compared to 33.1%. And for program F, we had 7% compared to 5.9%. And then the proportion of men accepted in programs C and E is not much higher than the proportion of women because this is 36.9% compared to 34.1%. And this is 27.7% compared to 23.9%. Now, if we take a look at the figure below, it's going to show a side-by-side bar graph of the results that we found in that table. The blue bars represent the proportion of men admitted for each program. The green bar represents the proportion of women admitted for each program. So you can see what's happening here for each particular program. Now, what caused the overall proportion of accepted men to be so much higher than the overall proportion of accepted women within the entire university when within each program the proportions differ very little and may imply that women are accepted at a higher rate? The initial analysis did not account for the lurking variable, which is the program of study. There were many more male applicants in programs A and B than there were female applicants, and these two programs happened to have higher acceptance rates. The higher acceptance rates in these programs led to the false conclusion that the University of California, Berkeley was biased against gender in its admissions. So, the Simpson's paradox. In this example, the association between gender and admission reverses when the lurking variable, program of study, is accounted for in the analysis. This illustrates a phenomenon known as Simpson's paradox, which describes a situation in which an association between two variables inverts or goes away when a third variable is introduced to the analysis. The results of this example serve as a warning that an apparent association between two variables may not exist once the effect of some third variable is accounted for in the study.